So welcome to this panel discussion on the role of standards for the management and the orchestration of containerized VNFs. This panel discussion is part of the HCNFV forum. It's somehow a follow-up on the presentation on NFV enhancements for containerized VNF orchestration delivered earlier as part of this forum by Jörg. I am Bruno Chatras. I am the chairman of the HCNFV Industry Specification Group, and I will be moderating this panel. We have 5 internationally recognized experts, all of them involved in NFV standards or in related open source initiatives. So I am pleased that they accepted our invitation to this panel discussion. Let me briefly introduce them before we start with a couple of questions. So we have Jörg Alken, who is a senior specialist on cloud-native industrialization at Ericsson. He is also the vice chair of the architecture working group of HCNFV and one of the so-called feature primes for cloud-native activities in HCNFV. So welcome, Jörg, to our panel.
Thank you, Bruno.
We have Taylor Carpenter, who is a partner and founder of the Volt Cooperative and co-chair of the Cloud-Native Working Group, Cloud-Native Network Function Working Group at the CNCF, the Cloud Native Computing Foundation. And he is also involved in HC, NFV, and make plug test activities. Welcome, Taylor, to our panel. Next, we have Ulrich Kleber, who is Chief Engineer Standardization, representing Huawei in multiple HC groups, including HCNFV, of course, but many others. And he is the other feature prime for cloud-native activities in HC. He is also involved in many other related organizations, such as Anuket and GSMA OPG. Welcome, Uli, to our panel.
Hello.
We also have with us Fernando Oliveira, who is a technology fellow at Verizon, working on network automation, orchestration, SDN, NFV, and cloud architecture in general. He's a member of the ONAP TSC, Technical Steering Committee, and he is one of the ONAP members driving the work on HC and ONAP alignment. Welcome, Fred, to our panel.
Thank you.
And we have Johan Trier, who is a network architect and manager as well at Docomo Eurolabs. He's the chair of the Technical Steering Committee, the TSC of HCNFV, and he joined HCNFV from the very beginnings, and as such he has been participating actively in the development of a basic NFV concept. So welcome, Johan, to this panel.
Thank you, Bruno.
I'm going to start with a general question that I address to all of you. I also invite the audience to put their questions in the chat during the discussions so that we can answer the questions in the chat as well. So the first question I'd like to ask to all of you is if you had to highlight a single key issue that standardization bodies or open source communities should address in priority with regards to the management of containerized VNFs or some people call them CNFs, but it's more or less the same concept. What would be the single key issue that you will put forward? It may well be that most of you will have the same issue in mind. That's not a problem at all. On the contrary, it will just show that this issue is important to the industry. So no problem if you provide the same answer. So let's start with in alphabetical order. So Jörg, it's your turn. If you had to mention only one key issue to be addressed, what would it be? Jörg, please.
I think it's interesting to consider and integrate the more autonomous orchestration platform for containers, which are provided by the open source solutions, into the existing orchestration stack we are specifying and standardizing in ETSI NFV. We have seen that there might be some conflicts, and that would be good that we could align and kind of leverage the capabilities from both concepts and align them and synchronize them.
Okay. Taylor?
I think that terminology and the shared language is probably the place I would say is a key issue between all the different communities and efforts. There's a lot of concepts, technology that are similar and have different terms. There's a lot of overlap where we can share things, and to be able to do that and learn from each other, we need to understand the language. What are the underlying challenges and sort of things? One of those that I'll point out right now is in the cloud native community, we say CNF is cloud native network function. So that's an important thing. And what do we mean by that, though? It's not just words. I won't go into that right now, but that's important.
Okay, I got the point. Fred?
Yes, so I had a similar to issue as what Jorg was pointing out, and I think there's some misunderstandings or miscommunications about the functionality between the NFVO and orchestration layers versus some of the autonomous functionality that's capable in the underlying platforms. Arranging the coordination between them, I think is a topic that very much needs to get addressed and appropriately resolved, such that the autonomous functionality doesn't interfere with some of the functionality that may be happening at different layers of the orchestration stack.
I do have a question on specifically on that, so I guess we will come back on that later. Uli?
Yeah, I would like to point to another point. There is a major pain point when we design containerized VNFs, which is in the issue that when we prepare VM-based VNFs, we would deliver the operating system together with the VNF, while with containerized solutions, we are depending on the operating system that is provided by the platform. And there we see that there are issues because many VNF products use services from the operating system, and this may lead to interoperability issues and difficulties to the VNF vendors because we don't know what to rely on. And here the standards and the de facto standards would help to have an easier integration, especially when we think about complex VNFs.
Yeah, thank you. So, and Johan, what's...
Okay, I think I will add a new topic. One of the issues, by the way, also I agree with previous ones. I agree very much with the issue that Fred highlighted. An additional one I say is the networking aspects. It seems that the networking in the containerized environments looks quite different to how telco and network operators were used to. There are new mechanisms and modes of connectivity in the container world that we had to newly embrace and newly consider. Also, when not just only for the deployment of the container environment itself, but also when it comes to connect the containerized VNFs to other functions in the network. And I would say that, yeah, that's one of the issues. And a little bit also related to other aspects, I think that Taylor also mentioned it. It's also about the ecosystem. I think that from the ecosystem perspective, I think that we also need to a little bit improve. We need to ensure that there's good collaboration in between the standard organizations and the open source communities, because we have to deliver stable specifications for longer term operation, and I think it's quite important also. And it's an issue that we could improve upon.
Thank you all. So we have a good range of issues to be tackled for sure. For many of them, I do have a more specific question. So let's see what else we can say on these different points. Well, I hope we can manage to discuss 5 points at least, maybe more. But of course, it's difficult to ask everyone to answer each of the 5 questions. So I will first address the question, each of the question to one of you, and just ask if the others want to add on top of the first answer. So the first question is on interoperability. This is interoperability, I mean, between, for example, between the network functions and the infrastructure, or between the network functions and the management systems, etc. So this has often been mentioned in the past as a major pain points for operators when deploying NFV systems, as a kind of roadblock in some cases. For example, many operators have complained or reported that the integration, for example, between a VNFM and OpenStack was not so easy, much more complex than expected. Now that we are switching to containers, there might be similar issues popping up. In the presentation you delivered, Jörg, before this panel on the overview of ETSI NFV activities, you explained that ETSI is developing a specification, SOL 18, which is a kind of profile specification, profiling, for example, Kubernetes, a Kubernetes API. Well, is this activity, from your point of view, is this activity intended to facilitate interoperability? And if yes, is it sufficient? And what else do we need?
Good question, Bruno. Maybe just to recap a bit, the approach we are taking here now for especially profiling a de facto standard solution, like in this case, mainly the Kubernetes API as the kind of interface API also from the which we try to integrate into the NFV Mano stack. We took a little bit of a different approach. So we split it into a first part where we specified more abstract generic requirements and specified an NFV object model. That is the specification which is numbered IFA 40. And this is what we're using as the baseline, and that would be, I would also say, the generic integration point for enabling, on one hand, the interoperability, but also enable the profiling, probably with multiple solutions and implementations. And the second step we are taking here now with the SOL 18, with the profiling of the Kubernetes API, and also partly for Helm and the OCI delivery API for the container images, is that we are basing this approach on de facto standard open source solutions, which we also think that they are highly adopted in the industry already. So we hope on one hand that these APIs we are going to profile against the NFV requirements are already generally adopted. So we are also kind of hope that the big adoption and also the big community behind these open source solutions already provide a big acceptance in the industry. Of course, we have to now consider also the telco specific requirements, which we specify on the other side, where we also profile these solutions against, and also we provide also for the interoperability and the integration the mapping of certain objects and data models and data model elements. So I hope that by this we can gain on one hand from the big experience and adoption from the industry on one hand, and the NFV side and telco specific side on the other side. But as I said, it's a little bit split between the requirements and the solution, and it also enables, in principle, also to profile another solution against it, if there is a certain future evolution on this or not. So I think yes, this definitely supports very much the interoperability. If it's sufficient, we have to see also what has been mentioned by Joan. It's still a very complex system, especially when it comes to networking aspects. And there we have to also see if we can integrate the existing open source solutions to fulfill all the telco specific requirements on that side. I would say that's to be seen if this is sufficient, but at least from the interoperability aspect, I think it's a very good approach to benefit from both sides. Experiences from open source and the telco and NFV specific requirements on the other side.
Thank you, Jörg, for this reply. Are there any other opinions on interoperability from any of you? On what is missing? What should we do to make interoperability easier? Uli?
I think this is a very good approach that we take there with the profiling. So I have good confidence that the interfaces on which we work in Sol 18, we will have a good interoperability on those. But on the other side, there is a limit how far those go. For instance, when we put a Helm chart into our VNF packages to execute it, we immediately lose control of that because we don't know what is in the Helm chart and how interoperable the content of this will be, and whether we come in the layer below what we are working on to interoperability issues that we don't solve because we don't address them in ETSI. So we depend on the de facto standards, how much they will support the interoperability in these cases.
Right. Any other comment, Johan?
Yeah, I wanted to add that I also believe that the Sol 18 is a very good step. I would say that it's a pity that we could not follow a similar approach also for other virtualization technologies. We were limited to do something narrow, for example, just only focusing on very specific aspects of the data model. I'm talking about the VM-based approach. But as important, I would say that it is Sol 18 in defining the profiling of the API. I think it's also very important what also Jörg mentioned about the mapping. It's very important to understand how we use these objects of the container orchestration and management, and how we map them to the actual objects we have in NFV. And I would say that here we'll enter into play a very important role also of other specifications. Like, for example, we have the Sol 16 on the end-to-end procedures in NFV Mano using the stage 3 definitions. And I think that the Sol 18 complemented with also those other specifications that can make references to Sol 18 will be really good also for enhancing the interoperability, because they will actually show the full spectrum, the whole context on how we can integrate this API with the rest of the system. So I'm looking forward that with the Sol 18 plus the pieces of other specifications, we are going to provide good baseline for interoperability.
So basically, you all think that the situation is better than it used to be. It is
better, but I want to also add one thing. I think it's quite challenging for ETSI also the approach of Sol 18, because we are stepping into a domain that we have to keep very good coordination with how the upstream solutions look like and how they evolve over time. Because we need to ensure that the specifications that we deliver are also delivered in a way that can keep backward compatibility, keep the development cycles of the operators that sometimes are much longer than the IT. So it's a challenging step, but I would say it's very important, and I welcome it.
Mm-hmm.
Okay, so, well, in the interest of time, I will switch to another question, but we can come back probably on that if needed as part of the concluding remarks. So the next question, I would like to address it first to Taylor. It's related to Kubernetes specifically. The question is very simple: is do you expect alternatives to Kubernetes to emerge in the coming years? For the time being, well, it seems to be the only de facto standard that is taken seriously, and as we just said, Etsy is building on top of that. But well, we never know what could happen. So you are very close to this Kubernetes ecosystem, so you are probably the right person to tell us. Do you see that there are some alternatives that could emerge maybe in 2 or 3 years?
All right. That got a little bit more specific with timelines there. I think I can tie this in also with the last, because we're talking about compatibility and interoperability. How do we go forward with what do we have now and what's going to change? So Kubernetes didn't come out of nowhere. It's built on ideas and technology that's been building over more than 20 years. With if you look at all the things, DevOps didn't come out of nowhere, Agile didn't come out of nowhere. All of these came to be what we say, what are cloud native principles and best practices. So I think that yes, there's going to be stuff going forward. I mean, I would say 5 years ago, if you were going to operational sysadmin systems type of design, big architecture that's going to be applied in many industries, then you were seeing a lot of different technologies. Definitely 10 years ago. Of course, including OpenStack, but multiple things. So Docker Swarm, was a big. There's a lot of other container-based, if we want to say that we're moving forward. And Kubernetes won out right now. Going forward, there may be something else. But modularity in computing is going to continue. Being able to say utility computing, that's what is desired by many industries. It's not going away. Now, how to make it easier so that people can grab something, plug it in, and focus on their business, that's what's going to keep happening. And cloud native principles, they're based around that idea, how to make it easier to do that sort of thing. They're going to be applicable to the emerging technology. So whether you're using Kubernetes or using something else, if you're adopting these things, that means adopting DevOps practices, 12-factor apps, all of these things can be adjusted for whatever your specific needs are, and then can be applied going forward. And that's why they're useful for helping stuff like what's going forward in 5G and the new, more modular ideas and stuff driving. I love the work that's happening, going back to compatibility, the comparisons, and we've had conversations during plug test and stuff that I want to continue. We're going to keep looking at that. Understanding those principles are more important in my mind long-term than understanding Kubernetes specific technology pieces. You got to know those to implement today. But if you understand the mindset, then you could say, oh, I could apply some of these right now with VM systems.
Yeah, sure.
Stuff there that you can benefit from. I think I could stop there because it all ties together.
Thank you, Taylor. Any comment on that, on potential alternatives to Kubernetes and the implications in terms of evolution, interoperability, and so on? If not, we can
Just a
Fred?
short comment. I mean, certainly, I think I agree with the notion of architectural changes and modularity is improving and can be applied across both containers and other VM or other kind of implementation methodologies. In this world of re-architecting applications into much more modular components that are independent of each other, I think is a fantastic goal. Again, in our world, it's been happening very slowly compared to some of the other kind of IT-based applications, but I think it's a worthwhile effort to pursue the general modularity and general independence.
Thank you. Well, now I would like to ask a question starting with Johan, but actually the question is related to a comment made at the very beginning by Fred, or at least that's what I understood from one of the comments from Fred. The question is related to the role of the VNFM and indeed the potential overlap between the VNFM and the mechanism that are natively provided by Kubernetes, for example. So anyone searching for information on the web can find white papers or blog posts challenging the need for a VNFM in a containerized environment. So, Johan, what's your opinion about that? Does the VNFM retain some value or not?
Okay, I'm not sure if I will answer in the most appropriate way, but let's try. So, first of all, I think I want to clarify one thing. It's about the VNFM and how it was specified. First of all, it's quite clear that sometimes we identify and we can really see that we are being provided things that are called a VNFM. But from the very beginning in the HCNFV architectural framework, what we tried to clarify is that that was a functional and logical architecture. And therefore, the functional blocks are logical and abstract, and they are just encompassing a set of functionality that is expected. How it is implemented, that is not mandated by the standard. So different implementations could happen. They could be, actually, I remember very well beginning the discussions we were having in HCNFV about whether we should or not merge the VNFM functionality with the NFVO. And I believe that at that time, what was happening is that we were already kind of assuming certain implementations. So that is, first of all, one clarification I want to do, because it's also how I will also answer the rest of the question, is that VNFM is the entity that we know that is responsible for the VNF lifecycle, and it's also responsible for requesting the fulfillment of resources of the VNF. And my question is, if what we are doing nowadays is actually to deploy network functions as VNFs, it's quite difficult to me to understand that there is no entity anywhere in the system or in the framework that is responsible for making a sense of those virtualized resources. So it is difficult, as I said, to me to understand there is no entity. And for me, that's one of the reasons that I would say that we always have a VNFM. Whether the VNFM is implemented as a specific piece of software that is independent from others, or whether the VNFM functionality is implemented as a controller that is running on top of another software that is also in turn responsible for some other tasks like resource management, I think that that is a possibility, because it's just an implementation. But I would say that logically speaking, we have a still VNFM-like functionality, as long as what we are deploying are network functions. In 20 years, we could argue, okay, we are not deploying network functions and we are deploying something different. Then, of course, we cannot call that thing that is responsible for managing the VNF a VNFM, we might call it something different. But for the time being, I would say we still have it. So whatever it is, it's implementation.
Thank you. Any other view on that? I guess some of you have already heard about that, these kind of discussions. Jörg?
Yeah, and here I fully agree with what Joan said.
Okay.
And that's also something when you ask the initial question, Bruno, when I mentioned what I think should do is to find out how we can integrate and make use of some of the particular capabilities which are provided by, for instance, container orchestration platforms. You can see them even logically fulfilling some parts of the scope which we have specified in the functional requirements on the VNF manager. But when it comes to integrating them and specifying how these, of course, it's also more maybe an implementation view, but how could we, excuse my words, stitch them together? I mean, we have at the moment, for instance, fairly clear specification. Just take one example, like scaling. So we have functional requirements on the VNF manager to provide certain capabilities to scale a workload, right? Based on certain, let's say, metrics or KPIs. Now we see in the implementation, like on the Kubernetes platform, they have also autonomous capabilities to provide these kind of autonomous scaling capabilities, which are on a higher level, more like configured that we give these container platform a certain range or a quota within which it can scale autonomously without further external intervention. And this is what I mean, just as one example, where I would see it very beneficial if we, on one hand, where we need the notion of the network function, which is for sure not visible in the container platform. The container platform doesn't know anything about the network function. It knows about its resource objects it is managing. To combine these two views, that maybe we can have and will still need the VNF manager to specify these kind of ranges, and then, but also implementation-wise, have the possibility to orchestrate on the network function level these ranges, but maybe leave the lower level orchestration business logic to the container platform. That's what I meant also, and this is something really interesting, and I think something we need to solve also with our architectural approach.
Thank you, Taylor. I guess you have some opinion on that for sure.
Well, some of it Jordan just said, so I agree with a lot of what was just said there. And I think it's what's you're going to see on Kubernetes, and I kind of repeat this again and again, is if you focus on just the technology, how it works, then you can end up with more conflicts potentially on integrating than if you understand why it was designed that way. So when you come and say, how are we going to specify these limits, or how do we meet these requirements? We need to make sure that these resources aren't overused by this and this sort of thing. There's thoughts on solving those in the Kubernetes ecosystem. And they're driven not just by the technology, but thinking like, how would you do this in I'm going to go back to a cloud native way. And Kubernetes is designed to be extensible. So you can look at the core part of Kubernetes, or you can look at, oh, you can extend this piece and have a little bit more control. And it's designed to do that. So I think there's places in the way it's been implemented. So what Kubernetes does is it's implementing these ideals. And there's ways to integrate directly into what was just mentioned. Like how would you take the logical view that you need that part, that's going to stay in there for the VNF manager. it's not about how it's implemented, it's are you going to meet those requirements? And I think those pieces are there, at least with regard to the way it's designed. Now, someone may not have a Kubernetes operator or a controller that meets the needs right now, but the framework is designed to be able to extend those pieces and match up. I'm going to stop there because I think Fred has some comments.
Yeah. Thank you, Taylor. Fred, yeah.
It's done a kind of similar vein of the, and again, from my perspective, it's not really just the VNF manager. It's really like delegation of function. I think the way Taylor was describing it, there are capabilities that can be used in the platform. And I think one of the things we need to figure out is how do we actually do delegation of these functions and the policies that would apply. There's some things of like scaling and healing, which would operate within, I'll say, some resource bounds that are handed to the framework. How do we manage those resource bounds? And can a model be provided such that a higher level orchestration can manage the resources that are available between the different components of I'll say a network function in this case, versus what in Kubernetes are basically treated completely independently. Each individual deployment or pod group is treated independently, and it might not be the scenario that is important in the scenario where there's limited resources in a operator's environment. And so how do you delegate? How do you manage the resource allocation between different areas of the stack that are operating this network function?
Thank you, Fred. Uri? You are on mute. I think you are on mute.
I would agree to all of that, but I would like to focus a little bit into another direction. When we look at the relation between the VNF manager and the orchestrator, I think there's also an important role of the VNF manager to provide one interface, for instance, for the service provider to just select a VNF, and everything that is inside that VNF is hidden through the means that only a VNF manager can fulfill, and thus it allows even a VM-based VNF and a containerized VNF being managed or seen for the service provider in exactly the same way. And therefore, I think it's very important to have that level of the VNF manager.
Thank you for that. Johan, you wanted to make a final remark?
I just want to make a final remark based on comments from Taylor and Fernando and also Jörg. These aspects of delegation or leveraging levels of orchestration that are also happening at the virtualized layer. This is not just only about containers. I mean, it's also possible in VM-based deployments. We know about certain orchestration engines that are available in those solutions that also provide very similar functionalities. And in the way that we define the VNFM, we were aware of them. So we were not trying to be or overdo the functionality that was already available. It's just complementary.
Understood. Yeah.
And as I said, it's just also available also for VM-based, not just only container.
Thank you. That was an interesting discussion or collection of views on the role of the VNFM, which is indeed sometimes challenged in the literature. Mm-hmm. I have a related question. Somehow it's related to the interactions between the VNFD, the VNF descriptor, and the Helm charts precisely. And so I will start asking the question to Fred, because I know that he is involved quite directly into that in ONAP and somehow in HC as well. So the HC approach, and this I guess was explained, if my memory is correct, this was explained by Jörg in his tutorial. The HC approach is to include in a VNF package a VNFD in the form of a Tosca template or a Young file with pointers to Helm charts, the Helm charts being themselves included in the VNF package. We can see here again, if you search on the web for information on the interactions between VNFDs and Helm charts, you can see various alternative solutions. So there is the VHC approach, but there are other approaches where you just don't use any VNFD at all. You just use the Helm charts, or you use a dummy VNFD with 2 or 3 fictitious parameters. And there are other extremes where you don't use Helm chart at all. You make you express everything in Tosca. So can you offer an opinion on the pros and cons of all these approaches?
Yeah, certainly. Thank you. There's first, I'd say this is a new issue. I think even when we're having VM-based VNFs, the descriptor was often not leveraged completely. Even in some of our early VNFs that we deployed, most of them were leveraging heat scripts of some form.
That's right.
Directly to the deployments. And because there was no ability to reference or correlate the effects of what was going on in the heat scripts versus what was going on in the VNF descriptor, these kind of disconnects happened. So in the various models that we've been looking at, I think the one that we've been looking at the most is incorporating I'll say a reference to the Helm charts in a VNF descriptor that is very similar to a VM-based VNF descriptor. The pros here, again, it's a relatively small addition to the various classes and capabilities to manage container-based network functions. However, you do lose some information or correlation between what's happening in the Helm charts versus what might be potentially described in the VNF descriptor. But again, leveraging this functionality of leveraging the Helm charts enables some of the functionality that's happening in the industry. There are people familiar with how to develop Helm charts, and kind of wrapping a VNF descriptor around them enables a reasonable intermediate mechanism for mapping these functions. Alternatively, there have been some proposals to, I'll say, simplify the VNF descriptor that's specified in ETSI Sol 1 or Sol 6 and for the Yang models to have a very light model where there's potentially just a reference to the individual Helm charts and no other information is maintained there. I think the kind of negative, well, I'll say from positive perspective, again, it enables a lot of reuse of the existing industry practices, can be relatively quickly developed into a descriptor that a vendor can provide to an operator. I think the big negative is the big loss of understanding of what's happening in the functionality. In decomposition of the network function into different Helm charts, different deployments, different sets of containers, you lose a significant information about what's going on in the function. And then kind of lastly, the capability of describing everything in Tosca and using that to, I'll say, through operator, through some orchestration framework, talk directly to the underlying the underlying platform. removes a lot of the kind of distinguishing aspects of, or loss of the correlation between what's going on in the underlying model, in that you can describe everything in the Tosca framework. However, you do, it is not industry accepted model, would require significant effort by vendors and operators to learn this new model, understand it, and develop the tools to actually enable it. Current orchestrators are not, at least that we've been familiar with, capable of completely orchestrating this kind of environment just using a Tosca model. That's all I have.
Thank you for this feedback, Fred. And I see that Jörg would like to add on some comments. Jörg, please.
Yes, thanks, Fred, for sharing that opinion. I think I share your opinion there as well. When it comes to the descriptors, I think what we also need to consider there is that those different types of descriptors are also processed on different abstraction levels and on different layers in the orchestration stack. So, for example, the more native templates like Helm charts, they are more processed on the lower container orchestration level. As said before, they are of course not aware of what is a network function or stuff like this, or how are these individual components interconnected. This is information which I would expect more on a VNF descriptor or even on a network service descriptor. So I don't think that this can be replaced. The only thing, that's what we are discussing right now, and I think Joan has also mentioned it once before, is certain parameter mappings, because I think we should only convey that information in the individual types of descriptors is on which layer they are interpreted and processed. And of course, we need to avoid that we on one hand have ambiguities when we combine those descriptors, and also reduce the kind of redundancy also to a minimum. So we should not try to model something twice in two types of descriptors. However, I personally don't believe that it's possible to automatically generate like Helm charts from a Tosca VNFD, because that would mean that all the capabilities of the native platform have to be somehow modeled in the VNFD. And I don't believe in that, because then you're just rewriting everything. So I would rather prefer that we really look on which information is needed on which layer in the orchestration stack, and then model that correspondingly in the appropriate descriptors. And then the rest kind of, the NFEO might not need to know everything which is low-level Kubernetes. You cannot do anything with that. It doesn't make sense to expose it on the orchestration level, just as an example. Yeah.
Thank you, Jörg. Johan?
Yeah, I would like to add about one of the pros of the Tosca-based approach. And I think one of the pros is that it offers also a technology-independent way to describe the VNFs, not specific whether they are VM or not. Of course, the VNF descriptor in the Tosca has to also enable the capabilities of whether to deploy VM or container. But it provides a level of abstraction that it's also good to ensure that we are not just sticking to a single technology. And also, from the perspective of an operator, it is also very good that we have such type of solutions, because it offers us a common way to understand how all VNFs can be deployed, because not all of them will be container-based. They will still be VM-based ones. And having a common language to express the requirements for them and to understand how we can life cycle manage them, I think is quite beneficial. So I would say that it's a big pro, and we should still look forward on how to enhance our Tosca descriptors to make sure that we can also deploy for containers and keep deploying for VM. So.
Thank you, Johan. Are there any further comments on this question? If not, I would like to ask a question to everyone still, but starting with Uli. And I will again refer to the presentation made by Jörg. So this is basically, as I said at the very beginning, this panel discussion is somehow a follow-up on the tutorial you delivered. So you explained that Etsy has developed a specification of functional requirements for cluster management. And actually, the specification is close to completion. So my question to you, Uli, and then to the other panelists is, okay, what should be the next steps? So Etsy has specified a set of functional requirements. What should be the next steps? Should Etsy start specifying APIs or profile as Etsy did for example, for the VNFM APIs or VNFVO APIs, or should rather Etsy try to profile de facto standards? But on the other hand, for cluster management, there are many solutions. There is not, perhaps it's not so easy as for Kubernetes.
Yes,
so what will be your recommendation if you were the one to decide what Etsy should do?
You are right. It's not as easy as with Kubernetes and our SISM definition. But still, I think Etsy should go as far as it is needed to ensure that we have interoperability. And on the other side, leave to de facto standards as much as can be left to them. So I think the introduction of the cluster management that allows NFV-Mano to dynamically create and manage the clusters, it contains things that are covered in de facto standards and therefore should be done in the same way as we do for the SISM with a profiling approach, but it covers also things that, for instance, go in the direction of resource management, which is not covered by the de facto standards in a similar way. And there we have to probably go the traditional way and specify more in Etsy so we can be sure that there will be an interoperable approach in the end.
Could you give could you give an example? Yep. Because I'm not sure that everyone listening to this panel will understand. So if you could give an example for each of the two categories, the things that can be supported by de facto standards and the other things.
So let's start with the other things, because when we set up a cluster,
okay.
We first have to provide the necessary resources where the cluster nodes can run on. And when Kubernetes is starting to setting up the cluster, it assumes that the nodes are already there. So when the cluster management starts creating a cluster, for instance, a cluster of virtual machines, it needs to create those virtual machines by using a virtual infrastructure manager. So they can be used afterwards, or it can use some other management system that can provide bare metal servers to do similar things. So it could be a lab as a service, it could be OpenStack Ironic, it could be an internal functionality of the cluster management with a pool of servers there that can be allocated to the to run the cluster nodes finally on it. But everything that will be after that done to establish a Kubernetes cluster and run that, this functionality is available in Kubernetes, so it just needs to be profiled. Of course, sometimes it's spread over multiple projects of Kubernetes, so we need to be careful with the profiling what we do there. But there, the de facto standards are pretty much developed, so we can build on that and do a profiling approach in the same way as we did for the SISM.
All right, thank you. Any other comments or views on container cluster management? Johan?
I think that someone said there are so many different solutions in this space In my opinion, I would say that it's a little bit difficult to assume that there is, or there will only one de facto solution, that we can really base the solution on it. In that regards, time will tell, but I have the impression that eventually some kind of a standard might be needed, not just only leveraging de facto standard. Whether it's going to be at CNFV or it might be maybe some other organizations or cooperation, collaboration in between organizations to deliver that standard, that we will see. But I think that it might eventually be one. And again, speaking from operator perspective, we believe that we need one because it sets the baseline for understanding how the system will be integrated and how we are going to fulfill all these cluster management functionalities. Without a very specific document or a specification that we can refer to is quite difficult because of, as I said, the whole spectrum of too many solutions.
Thank you, Johan. So, Taylor, is it something you are discussing at the CNCF?
I won't go deep into it, but just mentioning this is an important area within the Kubernetes community and how to manage the resources underneath. So as was mentioned, once you have the machines, there's a lot of solutions out there for setting up the clusters and setting up multiple clusters and managing multiple clusters. So it's the allocation of the resources to give to Kubernetes that's we're really talking about here. And that for the past, like I would say at least year and a half, it's been more and more active. And there's a special interest group, the cluster lifecycle. There's a sub area cluster API. So cluster API had been for a long time trying to make it really solid with regard to managing the existing clusters, how to set them up. And what's been happening the last, I'd say, year and a half to 2 years, it was before that when it started going as far as discussion, but implementation for allocating those. So it's there now, and you can do some of that now actively with Cluster API. If you want to say, I want to expand the cluster, I need a new machine. It's not even here yet. If you're on a cloud provider, which a lot of operators are starting to work, I mean, you have Azure for operators where AT&T is like brought over tons of them. So you're going to have stuff like that. Then they're providing APIs. And what Cluster API does is give you a standard for using any of them. But you also have bare metal needs, which we're going to get to next, of course. And that one is something where there's a lot of, I'll call it plugins or extensions. They're tying into that same API and saying, hey, we can use it. Some of them use technology that actually came from OpenStack on how to provision physical machines. So it's there and coming, and we need more input, I think, from the telecom community, which has those needs, back into these groups so that they meet the requirements from the telecom industry.
Thank you, Taylor. So we are close to the end of the panel. I would like to conclude with one general question, just to make sure that we did not overlook anything. So I would just like to ask you whether is there anything that we did not address but we should have from your point of view? Please be very short, just to highlight the point that we missed, and maybe this will give us some ideas for organizing another panel. So, well, any of you is welcome to highlight some points that we did not have time to address. Jörg?
Yeah, also in the future, I would appreciate if we could leverage even more on the extendability of the container platforms. Examples like custom resources, operators, all in this area. I think we have not represented that really much in integrating it into the NFV orchestration system. But I think they're really great capabilities we also might want to leverage on in the future.
Thank you, Uli.
Yeah, I agree with that. And another point that I think we cannot forget and have to work on is fault management, performance management, and these things that usually come a little bit later than the lifecycle management when we start with these topics. So how to do the fault management, how to notify on capacity shortages in a cluster and things like that. I think there are a few things that we have to address there as well.
Thank you, Uli. Yeah, that's an important point indeed. Any other comment?
I was going to comment quickly, but I think that we are running out of time. I just wanted to make another topic, which is more about collaboration among organizations and open source. I'm seeing still a lot of fragmentation, and we are even sometimes creating more fragmentation. So we should have more opportunities to discuss and try to collaborate more. I think that it's probably a topic that could bring new ideas on a future panel. So,
yeah,
right.
I absolutely agree, and I invite everybody to come join the CNF Cloud Native Network Function Working Group. We meet every Monday, and it is specifically about trying to help understand the solutions that might fit, right? If the mapping, all of the different stuff that we're talking about, we want to know the challenges and try to focus on like how we can work together.
Thank you, Taylor. So I guess we have to close this panel discussion. Of course, many thanks to all of you. I guess you provided some great technical insights on quite complex topics, and so I hope people watching this panel discussion have learned something, or I'm pretty sure they learned something anyway. So thank you very much for participating to this panel, for having responded positively to the invitation. And with that, I simply declare the panel discussion closed.
Thank you.
Thank you.
All right.